Yeah, so yesterday we I showed you some 3D stuff, the polyhedron, the new element polyhedron mostly, and uh, yeah, and shading. And Tom Tom seems to be I guess he was a little bit embarrassed because I showed his. So he sent us this subdivided or iterated icosahedron, and it contained a little bug. And yeah, so no, it's where is my here it is. So the the subdivided icosahedron has some dimples. What how does it how is it created? So we we start. No, let's do it in a JS fiddle. So we start with some iteration level. Let's say, where is it? 0. And though we have an icosahedron, and we take the center, the midpoints of these lines of a face, and this subdivides a triangle into 4 new triangles, and then we lift this or project this triangle to a certain distance from the origin, namely to a common distance from the origin, so that it will be on the sphere. At the moment, it's we projected that it has radius 2. Unfortunately, in his initial implementation, or fortunately, I have to say, these vertices are not in distance 2, the origin. And this was a little bug, but actually this bug was extremely helpful. And we are very glad that this bug happened, because of this we implemented shading and so on. And without shading, you really cannot see that there are dimples inside of the sphere. So let's do it. Let's do one more iteration. Then it's like this, and yeah, and 2, and so on. And yeah, in this. Oh, let's do one more. Okay, now you see the dimples better. And yesterday, Tom suggested a bug fix, which is simply we have to lift or project or scale the initial vertices, though they have distance 2 from the origin, and you simply have to uncomment this line in the middle, and then the dimples are gone. But in my opinion, the resulting object is less interesting anymore. But it's a usual way to approximate a sphere. But now what you are seeing is that this sphere, regardless if you have the dimples or not, is quite demanding for the browser. You see the shading lags a little bit behind, This is because of the reordering of the SVG. And though this is a lot of work for the browser, extremely lot of work for the browser. And I have a canvas version of it in our examples database, now without the dimples. And so instead of the default renderer SVG, here the canvas renderer is activated, and this is much, in this case, so the renderer, canvas renderer for those problems is much faster. Maybe it's much faster. So if you have an application which is a little bit over the top of the SVG renderer, you might try the canvas renderer. Of course, there are some other restrictions then, but it might be an option. So we will in one of the next versions, the polyhedron will be one more options for surfaces, so you can fill the surfaces. So you will have an option beside the mesh. Now, for surfaces are displayed in a mesh, so polyhedron will be a different or another alternative way to display surfaces. This will come in one of the next releases. Then we now have also 3D transformations. And at the moment we have it for points, lines, planes, curves, surfaces, and polyhedra. Maybe more elements will come, but at the moment only these elements are supported. And though there are several possibilities how to apply a transformation. We can just create a transformation, and then we can apply it once for an element, or we can add it for the rest of the existence of this element by adding a transform to an element, and we can create a new element as a transformed copy of another element. So we start with an element and create a new one and supply a set of transformations which transform surface to surface one. And this might be the most confusing code. We can add, while it's more or less the same, we can add for an existing element like surface one, we can add a transformation, and the transformation will be on the basis of another one. So this may be, it's internally done, so probably you don't use this one. At the time being, there are the following transformations supported. So we have a translation, scaling, rotation, general rotation about 3 axes, and about the x-axis, y, and z. Maybe I show you the API docs for the moment. And though a transformation is now, a transformation means in 3D means we add our we have some points in 3D, some coordinates in 3D, which are homogeneous coordinates, namely of length 4, what I explained yesterday. And a transformation now means we multiply this vector with a matrix of dimension 4 times 4. And this was one reason why we had to refactor all the 3D stuff again, to that internally everything is handled with homogeneous coordinates. So let's look at an example. Now, what we do have, what's here? So we have 3 points, one free point, and 2 translated points. How is the dependence? So we have a slider. We'll say about this we'll use it in a minute. We have this 3 points. This is drag me. And now we have 2 translations, 2 transformations. So the first is T1. It's a translation by the vector 2, 3, 2. And this one is, well, let's just show this one. So then we have this translate fix and this new point. And it's the first point translated by this first transformation. So it's a fixed translation. Okay, maybe from looking from the top, so it's like this. Okay, then for the second one, the second transformation is a translation, and it's translated by a dynamic vector. Namely, the x-coordinate depends on the slider value plus 3 and 0, 0 for y and z. So let's look at this. And this is why parallel projection is sometimes also to be recommended. So now we translate by function, and yeah, this translation depends on the slider value and can be changed during the setup. Okay. Then the next what I want to show you is transformation of surfaces, and well, this I start with a basic surface, this one, and I add one transformation, and this transformation depends on the first slider. So I can transform this basic surface. It's a rotation around the x-axis. And the angle is defined by this slider. It's given by this slider. Okay. So the surface transforms itself. Then we create a new surface with, let's say, some dummy dummy content, doesn't matter. And now we make this surface a transformation of the first surface. And at the beginning, it's the same. If I rotate around the x axis, it's both surfaces stay the same. But the new surface also has the transformation around the y-axis. You can do this and then translate everything like this. Okay, and finally, let's say the most recommended way would be to have a surface, to create a new surface as the transformed surface of another one. This is the green one. Let's do it like this. And as you see, it has the transformation T3. It is a rotation about the z-axis, and it looks like this. And of course, it takes another one. Yeah, and it's getting 3D transformations are getting complicated very soon. And then the next example, you can try it out for yourself, is with a polyhedron. It's more or less the same. Here we have the first three transformations are act on the initial cube itself, and then there's a fourth transformation, which is a translation. So I can take this cube out and, for example, move it like this around the z-axis, x-axis, which means that this transformation acts twice. First on the initial surface cube, and afterwards a second time on the second cube. So yeah, okay. And one of the next upcoming tasks in 3D will be to display intersections of polyhedra or elements more exactly. So yeah, so to handle this correctly. Yeah. So if there are requests, we can we will add more translations and more transformations. And well, what's missing at the moment is the type generic. So you just can supply the 4x4 matrix and whatever it is, so you can implement your own transformations. Yeah, and then the 3D best practice. There was if you look at the Moodle course, there was a question by Leslie Wong, who is in the audience, about 3D, and he had a problem that the 3D view behaves differently if one uses a mouse or the finger. He supplied videos, and the problem is this are the default values for zoom and pan. So at the moment, the default value for panning is false. So you can pen with one finger, and if you change it to two fingers, though, you have to use two fingers to pen, and then this problem is gone. Or you do it like this, just disable penning and zooming, so all the events will be delegated to the 3D viewer. This will solve Leslie's problem, which happens quite often. Okay, this was what I wanted to say about 3D, and I want to present you a very subtle but for programmers very important feature, which I hope that you have hoped that this will exist in former times, in previous versions. So it's a bit difficult to explain it in words, though we have the availability of this or self in attributes function. Or attributes functions are executed with a JSXGraph object as parameter. What is it? Let's look at this example. And so we have a state. So let's stop this for the moment. Okay. So we have a point, a free point, which is there. And then most attributes of elements are dynamic, which means that inside of a why is the point called static? Because it has a constant size equal to 8 at the moment. And here's a dynamic point, so to say. Its size is defined by a function. And what is it? The size is 2 plus 5 times the x value or x coordinate of this static point. Okay? So let's show it. So the point itself can be dragged around and it doesn't change. But if I change static, the size of point dynamic depends on the x position of static. Okay. Yeah, this was there all the time since ages, so to say. But now, we can do it for the point itself. So if we want to make in this dynamic 2 example, we want to have this point's size depend on its own x position. So like this. And this is now possible. You just supply this parameter self, or you can call it x or t, whatever you want, and use it. And this parameter is a handle to the point itself. So the only thing you cannot do is use this, because this has a different, it's a reserved keyword in JavaScript. The recommended way is to use itself, the most self-explaining name. Okay. Before this new feature, you had to, you couldn't do it. You would have to say dein. Afterwards, you would have to set dein set attribute size and then dein to like this. It has yeah. I don't want to. Oh, 2 + 5. You had to do it like this, and of course, if you have many elements, this is a mess, and it's not nice. So here, this is a very this is much more elegant, and here's a second example with some sort of heat map. So we place many points in dimension in the two-dimensional space, and the fill color depends on the point's x coordinate. So the face is a quadrangle, and the fill color is depends on a function depending on the coordinates of this point, and the same for the size. So it's like this. And this function also depends on a slider. So this, and doing this with set attribute, it would have been a mess, and here it's much more elegant. So this might be useful. Okay. So one word of warning: for certain values, this is not possible at creation time. So sometimes, if it's crash, you have to. So, for example, if you want to create a slider, and the size should depend on its own value, then you have to check if this value method already exists, and then you can do what you want to do with it. Otherwise, you have to supply some meaningful default value. Okay, then next point: accessibility with JavaScript or with JSXGraph. And for this, we have a few new things. We support now area attributes for all JSXGraph elements. So what are area attributes? The area stands for accessible rich internet applications. We had this very nice talk yesterday. And so usually, if you look at MDN, there are each HTML tag has a lot of attributes connected with area. So you can set a lot of area attributes, whatever they mean. Okay, and so for example, area invalid, area read only, area value max. And now you have this area attribute for JSXGraph. You can enable it. By default, it's set to false. And then you can set, for example, label or live, which is a shortcut for area label. So and live is a shortcut for area live, which means area live. Yeah, it's this attribute, and area label, it's this attribute. And these attributes are automatically set. For example, and for this attribute thing which I explained a minute ago, also very helpful. You can supply the area label, for example, some string about the position of this element. And then an area reader, which maybe a visually impaired user has activated, will read this string. And this will be all the time, it will be it will contain the most actual value for X and Y and name. Okay, and this is available for all elements. Of course, you have to use SVG, the SVG renderer, to have this available. Yeah, maybe we should enable it by default for some elements. I don't know. Here I need some input from experts. I have no idea. And then there's a second feature, keyboard navigation. We have now the element, the tab index at the moment, and this can be set for every element. At the moment, it's turned off. The default value for in HTML is -1, so it's not reached by tapping on the tabulator key. If you turn it off, turn it on by setting the tab index to 0 or something else, then it's active, and the element can be reached by the tabulator key. First, when we introduced this feature, we turned it on by default, but this was too much, and it was turned off again by turn it off completely. I don't know what is the best solution. Maybe something in between, and have it turned on for, let's say, points which are not private points or sub-elements of other elements, something like that. We have to go through the whole elements and decide for each element which are should be turned on by default. So I would be very grateful if you could help us and give some advice what should be active by default. And the next thing in respect to accessibility is colors for color blindness. We saw yesterday, we saw certain their own app implementation for using special colors. We have implemented the so-called Bang Wong palette. There was a blog post displaying the problem, and there are certain palettes which optimize colors for certain types of color blindness. It depends a little bit on the type of color blindness, and we implemented this palette. And if you go to our API documentation, then if you choose JSXG palette, black, blue, green, purple, then these are used by the Wong palette, which is also part of JSXGraph, which uses this fixed values. So yeah, you may try it out. It's certainly helpful if you. I'm colorblind too. So if there's a companion text and it's written drag the red point or drag the green point, then it's often hard to distinguish what does the author mean. Okay, then finally you have some various things. At our 24 in-person meeting in spring, Tom suggested that he does not like the JSXGraph way how to supply a curve by giving an array of x coordinates and giving an array of y coordinates. He wanted, or he suggested that we should supply an array of coordinate pairs. So xy coordinate, xy, 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 and so on. And this is now possible. You can do it like this. But you have to surround the pairs by another pair of square brackets to avoid disambiguities, to avoid confusion. So here we have this 4 points. We start here, then there, go to here, and go to here. And yeah. And this might make it much more easier for many of you to implement a polygonal chain. And as you see here, we use the Wong palette or the colorblind palette. Here it's a certain kind of blue. Yeah, and then another outcome of the 24 hours meeting was while using the ES for JavaScript ES6 version for animations. So what is it? Let's look at the example. So here a point moves. Yeah, it does something. So what is it? Let's break it down. We have some point, and we want to move it to move to -3, and in a period of 1 second. So like this. Yeah. Okay. And now the request was, okay, if we want to combine several animations, and for this we had to supply callback functions. And though if you do it several times, we have a huge amount of callback functions, which is not very nice. And JavaScript had addressed this, and this means you can do it now like this. So we have the first animation, and if this is done, as soon as it is done, then, of course, then there follows a second animation. And so it's like this. Yeah. And of course, you can continue this. And now another another animation, and so on. And you can combine these animations all together. So we have several animation types: move to, move along, and visit. And that's it. And you can combine it in a very, so it's a very convenient way to combine several animations. And the next thing is we have automatic label placement, auto position. We have improved it a little bit. And it, though in the first version of this auto positioning, the labels were jumping around quite nervously. And here they are more quietly jumping around, or not so jumping around that much. Of course, everything has its limit, but I hope it's an improvement. And then now a little bit of new mathematics. We have improved or visit the convex hull algorithm. So what is it? Here we have some random points, and we could create a curve. This is now at the moment it's buried quite deep in the math library, because I doubt at the moment I don't feel that we need a dedicated JSXGraph element for it, but if you want to, we can do it, of course. Yeah, so we have this set of points, and we compute the convex hull of these points. And it's looked like this. So this is this polygon you see outside, and it goes around all the points. So, and can be stretched by points, of course. And the second application, sometimes you may just ask if the point set is convex, and we have this method, is convex. And finally, we come to the fun part. Namely, previously, we had text elements and image elements, or mainly text elements, which were actually they were, if you choose display HTML, it's just a division inside or above the SVG picture in technical terms. But now we can, it's possible to add or to supply every element, every JSXGraph element with this, with its own CSS class. Of course, this is available for SVG only. So otherwise, for Canvas, it's not possible. Yeah, okay, we can do it, but I have to warn you. So if there's a dedicated attribute for it, for example, for font size or for size, then this attribute has priority if you change it, if you use it. And yeah, but now we can, but everything else you can override with CSS classes. And let's just have an example. Here it is. So what we can do is we can add some SVG filter. It's a very common thing or very easy to thing to have SVG filters. So pattern 1, pattern 2, or turbulence. No, the filter is handwriting, and then we have pattern 1, pattern 2. Yeah. And now we define some SVG, some CSS classes like handwritten, which applies the CSS key filter and uses URL handwriting. So it takes this filter, yeah, it takes it. And for area, for example, we have fill, we have this pet1 or pet2. Image, we have also fill, area high, and so on. And how can you apply it? For example, this point A, its label has the CSS class handwritten and the highlight CSS class handwritten. So it takes this filter, this handwriting filter, and also the face itself. It's an X across, and it also has the CSS class handwritten, and then it looks like this. And maybe for one more for the circle. The circle also had this CSS class handwritten, and yeah, pattern. I don't see it at the moment. I don't know if yeah, it's very funny. So you can create an old style picture. But I have to warn you, the Safari, you have to try it out also on the Safari. For certain filters, Safari will become extremely slow. So Pedro asked, how do you control the CSS of the arrows of the axis? Yeah, the arrows, these are difficult. Maybe I cannot do it today. I will. You mean the arrowheads, probably. I will have a look because
yes, precisely. Yeah, we weren't able to handle the arrows of the axis, the heads. So if you have a solution for that and can send it to us, that would be great.
Yeah, I will have a look at it tomorrow. So I will answer you in the forum. Okay.
Thank you.
Okay, so this is the fun part, and I hope it was kind of interesting, and I hope you continue to use continue to use JSXGraph and have fun with it. And yeah, that's it for today. Are there any questions or more questions?